to continue our discussions, we'll discuss about antibacterial medications that inhibit nucleic acid synthesis. Because nucleic acid is a biomolecules that is needed for the uh, multiplications and growth also of the bacteria. So these antibacterial medications target enzymes required for nucleic acid synthesis or inhibit that enzymes. And we have fluoroquinolones that maintain the inhibit enzymes that maintain the supercoiling of the closed circular DNA known as the topoisomerase 4, and ripamycins block the prokaryotic dependent RNA polymerase from initiating transcription process. So because DNA is needed in the transcription process, so if you block the DNA dependent RNA polymerase, so there is no nucleic acid synthesis that will happen. So sulfonamides, or we have sulfadiazine, well absorbed orally, used to treat urinary tract infections, but many strains of E. coli are resistant. Escherichia coli are resistant to sulfonamides, so use less toxic drugs instead. Adverse effects, allergic reactions, skin rashes, fever. So trimethoprim used for urinary tract infections and respiratory tract infections. We have also trimoxazole, yung trimethoprim plus sulfamethoxazole. These are used for commonly in pneumonia, myocarditis, and toxoplasmosis. So antibacterials competitive inhibitors. So this is the mechanism of sulfonamides or sulfa drugs. When you say sulfa drugs, because they're based on their structures, they contain the sulfur group or sulfa group, or the SH, tawag doon pang thiol group. Inhibit folic acid synthesis, and it is known to be a broad spectrum antibiotic. So normal binding of substrate. So as we recall, parang pareha rin niya sa mechanism ng enzymes. So we have the substrate, we have the active site, and then the enzymes, or known to be the apoenzymes or hollow enzymes, which is known to be the active enzymes, correct? So when you say competitive inhibitor, action enzymes inhibitor, so the antibacterial drug act as competitive inhibitor, wherein it inhibits the binding of the substrate, okay, with the enzymes. So usually actions enzymes inhibitors altered active site, and we have the non-competitive inhibitor or allosteric site. So usually this one is a non-competitive and this one is competitive. So the antibacterial inhibitors compete with the substrate in binding with the enzymes. So usually ito yung naga-inhibit ng actions ng enzymes, okay, that will bind with the substrate to be needed in the DNA or nucleic acid synthesis. So yun ang mechanism ng antibacterial. So hindi tayo dito dili lang kita sa competitive inhibitor, because this is the mechanism of actions of antibacterial sulfonamides, or the mechanism. So what will happen? So we have the para-aminobenzoic acid. Para-aminobenzoic acid is converted to dihydroteroic acid that is acted by enzyme dihydroteroate synthetase enzyme. So this one is being blocked by sulfamethoxazole or sulfonamides. Or if there is, or another mechanism wherein, example, na-convert, mayroon pa rin mga dihydrotetroic acid, pwede pa rin siya ma-convert into tetrahydrofolic acid, okay, or dihydrofolic acid, which is acted by glutamate, okay, and dihydrofolate synthetase enzyme. So if that dihydroteroic acid is converted to the dihydrofolic acid, then it undergoes another reduction process. So NADPH is converted to NADP, meaning there is a removal of one hydrogen here. So that is acted by enzyme dihydrofolate reductase enzyme, okay. And your trimethoprim antibacterial, or the sulfonamides, blocks the dihydrofolate reductase enzymes. So, kung i-block niya ito class, hindi na ma-convert si dihydrofolic acid into tetrahydrofolic acid, which is needed for RNA, DNA, and protein synthesis. So, this is the mechanisms of the sulfonamides. So, again, the PABA or para-aminobenzoic acid. So, this one class, diri ko na lang i-discuss one isa-isa ha. The PABA or para-aminobenzoic acid plus pyridine is converted to dihydroteroic acid that is acted by enzyme dihydroteroate synthetase enzyme. So, this reaction is being blocked by sulfonamides. Then, if the dihydroteroic acid is converted to dihydrofolic acid, which is acted by enzyme dihydrofolate synthetase, and also the addition of the glutamate. So, mayroon tayong dihydrofolic acid. Itong si dihydrofolic acid, again, it will undergo reduction process that will converted to tetrahydrofolic acid. So, that is acted by enzyme dihydrofolate reductase. So, NADPH is converted to NADP, wherein there is what we call removal of hydrogen. But this reaction class is blocked by trimethoprim drug or sulfonamide. So, if there is what we call this one, if there is no tetrahydrofolic formations, then it will affect the DNA, RNA, and protein synthesis of the bacterial cells. Okay, so we have here the PABA, so this blocked by sulfamethoxazole, and then we have the hydrofolic acid to tetrahydrofolic acid converted by trimethoprim. Okay, and then because your dihydrofolic acid is precursor of the proteins, DNA, or RNA, and DNA production. Okay. Next, we have quinolones or GABA antagonists inhibit DNA gyrase. So, tawag nalidixic acid is a quinolone used for UTIs. We have ciprofloxacin, or ciprofloxacin, 6-fluoro substituent that greatly enhance the effectiveness against gram-positive and gram-positive bacteria. This is ciprofloxacin. Okay, well absorbed orally in IV, eliminated large change in the kidney. So, side effects, take note, headache, vomiting, nausea are rare, but convulsions may also occur. So, we have here the gyrase or topoisomerase 4 plus the DNA. Then, yung combination of the two will form gyrase topoisomerase topoisomerase 4 DNA complex. Okay? So, this one is converted again, yung fluoroquinolone gyrase DNA complex or the fluoroquinolone topoisomerase 4 DNA complex. This one class, DNA broken down by restrained by topoisomerase subunits, then DNA synthesis, cell growth will be blocked. If the fluoroquinolone is given, your fluoroquinolone will going to block the gyrase topoisomerase complex. So, take note, this is the reversible reactions. So, release of the broken DNA will lead to cell death. Kasi itong complex class, take note, once topoisomerase 4 or gyrase enzyme binds with DNA, usually it forms a complex, correct? So, this complex is needed for the DNA synthesis of the bacterial cells. So, of the gram-negative or gram-positive bacteria. Usually, these are bacteria, ito yung nag-cause ng mga urinary tract infections. So, to break down that complex, so fluoroquinolone is given, and then if that DNA broken down class is broken down by quinolones, it will lead to release the DNA and it will cause the cell death. You have 5-nitroimidazoles. So, wide spectrum antibiotic. Kung say wide, madamo Japon ang iya na ma-inhibit o ma-kill na bacteria, both gram-positive and gram-negative. Metronidazole against anaerobic and protozoan infections. You have tinidazole, longer duration of action compared to metronidazole. Diffuses into the organisms where nitro group is reduced and chemically reactive intermediates are formed that inhibit DNA synthesis or damage DNA. Usually ito yung mechanism wherein the nitromidazoles diffuses into organisms where the nitro group is reduced. So the reduced nitro group, so it will chemically reactive intermediates are formed that inhibit the DNA synthesis also. So antibacterial that inhibits nucleic acid, again, we have the sulfonamides, sulfadiazine, sulfamethoxazole. So usually they inhibit the dihydroteroic acid, the dihydroteroic synthetase, wherein the para-aminobenzoic acid plus pyridine is converted to dihydroteroic acid. So as a recap na niya, so pwede yan inhibit ng cotrimoxazole or combination ng trimethoprim. Pwede rin mag-inhibit dito ng dihydrofolate reductase enzyme, itong trimethoprim. So the conversion of dihydrofolic acid to tetrahydrofolic acid. Kasi ito yung purines and pyrimidines are needed in the synthesis process. But itong mga nalidixic norfloxacin, ciprofloxacin, okay, to correct kagina, are needed in the inhibition of the gyrase or topoisomerase 4, which enzymes maintains the supercoiled DNA and needed for protein synthesis. So to inhibit this one, so magkaroon ng natawag natin na broken down of the DNA that will lead to the death of the bacterial cells. So 5-nitroimidazoles, we have metronidazoles, tinidazoles, and even ripamycins also inhibit the supercoiling of the DNA, which lead also to the cell death. Okay. So usually all of these drugs inhibit the nucleic acid synthesis. Okay. If you try to see inhibition of these enzymes, so hindi siya magkaroon ng inhibition of this enzyme prevents the DNA synthesis also. Okay, nucleic acid. So like trimethoprim, sulfonamides, quinolones, and nitromidazoles. Next. So we have antibacterial medications that injure plasma membrane. So we have polymyxin B binds to membrane of the gram-negative bacteria and alters permeability. This leads to leakage of cellular content and even cell death. So if there's a leakage of the cell membrane, so all other chemicals or toxic chemicals will enter the cells, and it causes also an injury to the bacterial cells. Okay, so kung may leakage siya, pwede yung magsulod ang mga other toxic to the bacterial cells or toxic chemicals or foreign chemicals will enter the cells freely. So these drugs are bind to eukaryotic cells to some extent, which limits their use to topical applications only. Okay. So ito mga topic, mga ointment. Antibacterial drugs inhibit the essential metabolites. Okay. The competitive inhibitions of substance that resembles normal substrate with enzyme, and mostly yung mga sulfur drugs inhibit metabolites. But later on we will discuss in your organic medicinals or organic tree all the anti-metabolites. So we have Kirby-Bauer method of determining drug susceptibility. So bacteria spread on the surface of the agar plate. Okay, 12 these each with different antimicrobial drug placed on agar plate. So incubator drugs diffuse outward and kill the susceptible bacteria. Okay, so this one, the zone inhibition around each disk, compare the size of zone to the chart. So this one is the method of determining the drug susceptibility of the bacteria and even the sensitivity of the bacteria. And by determining the zone on inhibitions, this one is the zone on inhibitions. So makita nyo, if this is bacteria is effective if this antibacterial drug is effective to this example, kung bacteria nito is gram negative, and then we have the the quinolones. So for example, this is quinolones, makita nyo zone inhibition, meaning hindi magkaroon ng colony sa diameter ng antibacterial na ini. So this is the antibacterial samples. So makita nyo kung effective siya, may zone of inhibition yan. So kung hindi siya effective, makita nyo gamay lang yung zone of inhibition niya. Okay. So this is the susceptibility test or drug susceptibility test for a certain bacteria. So this is considered to be very this give an evidence, on how the antibacterial cells responds to the certain bacteria by looking to the zone of inhibition in the bacteria culture.